I'm going to do a little intro, then John Heasley of Vario, and who's also channeling Hank Kilmer, an old friend of many of ours, who has sick dogs and didn't come. We'll talk about kind of the operator view. Phil from Juniper will talk about the current internet draft in the ITF by him and Rob Enns, who's also wandering around here. And then Andy Bierman, who's one of the chairs of the ITF-WG, will talk about where things sit in the ITF. By network, what happened in the ITF is a couple years ago in a March meeting in Minneapolis, it was very cold, and the network operators were saying, the network management people, I don't mean the people with suits and pointy heads who run around the top of my company, I mean the people who do SNMP and network management workstations and stuff like that, kept saying, why are you operators complaining? And what do we really need here, etc. And I said, how many operators are there in this room? There were about 30. And I said, of all those operators in this room, with those who have SNMP set enabled, please raise their hands, and none did. I.e., nobody's configuring routers with SNMP. The net management folk, of course, were shocked. There's an exception, which is DOCSIS modems, by the way, are SNMP managed. But for the most part, people are configuring routers with a CLI. There are two flavors of it. This is what smart people do, which is sneeze. We'll see if I can stop it. They take data which is defined either the global routing, both the global routing registry and their local database, which is I call it the local routing registry, but what's configured, what my customers are, what their address space is, et cetera, and you run some code and you generate the configurations and you blow them out to the network. There is a very common opposite practice, which is you have people that you hired in from Starbucks who keyboard to the routers and change the configurations continually, and then you wonder why your network doesn't work. This is very common. It's especially common in the large telcos, where the price of an engineer is considered more important than a running network. And they have a saying, the network is the database of record, i.e., these configurations are the real network. The stuff we have in our database, well, we try to keep up with that. And this causes long-term problems. So we're trying to come up with why and how you configure your network. And Woody did a draft operator requirements document, and it had some good stuff about the command language interface, using text, secure transports, etc., but it was kind of a small operator view, not the large operator view. And the joke that we started circulating around ITF, it's the CLI, stupid. But why was it the CLI? Why is the CLI what's important? And it's mostly because text, the CLI is text, and text is universal. It's malleable with lots of tools. I can send it by email to my friends. I can run grep on it. I can generate it with disgusting languages like Perl or M4. Okay. It's also, the CLI wins because the vendors take 5 years to get the MIB done for a new feature, but for them to test their new feature internally themselves, they have to hack it into the CLI. So when it ships in beta, I've got it in the CLI. I don't have it in the MIB. So the IAB, the Internet Architecture Board of the ITF, held a little workshop about 15 months ago with some network management people, some operators, some protocol people, et cetera, to try and sort out what the threads were here. The result was an was a XML-based effort known as XML Conf. There was a design team within the ITF. This is the first draft to come out of them, and there's a working group in the ITF. And that's currently the state of play today. I personally just want to push a high-level vision. I'm interested in configuring networks, not just devices. So this leads me to things like transaction models, right? There's usually two routers on the ends of a link, not just one. And I need to configure them both, and the problem cascades through my network. When I want to change my routing policy, I want to change it in my entire network. Okay? Security, identity, authentication, authorization, where the administrative and security boundaries are in my network, trust of peers and registries. These are the architectural issues that I think I need to solve. The language issues are what we focused on so far, and how to achieve these. I think next, we've threatened to have John Heasley up, and I'm going to have to do some laptop magic to make this work.
To apologize because I'm not really much of one with PowerPoint or anything like that, so this is the best you're going to get. Black and white and some web interface. Volume? Closer? Better? All right. So I guess my purpose is here to, based on my experience having automated a bunch of stuff for Vario and some other companies, to express what my opinion is about, and I hope I share it with a lot of other people in the field, what we'd like to see from an XML configuration interface, or more precisely a management interface that is programmatically run or defined. And you've all heard this before, I think, in one way or another, especially if you visited any of the or seen any of the drafts or visited any of the working group meetings. As Randy mentioned before, everybody did everything directly on the router. And in the long run, you pay for that. You pay for it dearly. When there's a problem, you can't do anything but panic, and you have no canonical config to refer to. So what is correct, and what is an error that has been introduced, and generally introduced without your knowledge. So as you hit these problems, it's going to be fairly obvious that this doesn't scale, as Randy always says. You're spending the majority of your time fighting problems than you are supporting your customers, adding new features, and generally managing all the other things you need to do. So one way to break out of that, and I think that a lot of folks have done this, is to start generating your configs, which is what Vario does, and I hope that a large majority of ISPs do, because frankly, if you don't have generation, if you don't have this kind of management, you're going to lose. There's no ifs, ands, or buts about it. So what we've done is we have a database back end. We have a bunch of homegrown tools. The tools that are coming from, or in the past have come from companies working towards this market have really missed the mark. They don't have the flexibility, they don't have what we want at all. And the number of companies doing that is fairly small and probably growing smaller, I would gather. At least from the service provider's point of view. The enterprise eats this stuff up, and companies like Juniper and Cisco and so on, I don't see how they could really avoid getting involved in that to some degree, because the enterprise likes the HP OpenView, the SNMP manageable, or rather, everything is a GUI management system, and that just doesn't work for the provider generally. Right? Your NOC needs to have those kinds of tools, but you don't really want them to be configuring your network. So you have to provide what the actual managers of the network are doing, or want rather. And I think that is simple tools, almost grassroots, if you will. Nothing overly complex, and it really doesn't need to be overly complex. Sort of beauty and simplicity. So we take all these database entries that define our peers, MSDP, general things about a device, and we build complete configurations for those devices and push them out onto the device when we need to make changes. And never use write mem or what is the other Cisco command to save the configuration. I've forgotten what it is. But anyway, write mem. We perform daily tasks that are all scripted. We perform our own monitoring, consistency checking between the devices and the database and vice versa. And I think that really the important part to take away from a lot of this is that not only is it automated, but we put the data in once and it comes out multiple times over and over again to serve for input to various tools, and you reduce the number of discrepancies that you introduce into your network, as well as the amount of work, the investment that the operators have to make in order to make the network function properly. So we do, let's see, eventually. What do we want? Well, we don't want some massive system that we have to not only manage the network, we also have to manage this monstrosity of a management system like HP OpenView. Great thing for a NOC, doesn't work for doing network management, especially not, I think, from the service provider point of view, and certainly not from Vario's point of view, and I believe a lot of people in the industry share that opinion. And we'd like to avoid the different interface for every single vendor problem. Yeah. And I think that one way we can do that is a lot of the things that you have to do, or rather configure on your devices, is the same for all of those devices that use a particular feature. Be it BGP, for example. They all have peers, they all have policy. Granted, the policy knobs, the way you configure your policy is different on each device, but from where you start, those can all be done in the same way. The same kind of syntax which can be translated to the vendor's format. So while a lot of vendors will say, we want to be able to introduce our own features, we want to differentiate ourselves from our competitors, that's fine. But for these things that are common between all vendors, I want to see things that are or that can be done generically. Right? I can configure a BGP peer generically. It has an IP address. It has a policy. It has a source address, whatever it may be. There are a lot of things that are compatible on that. Same way, every car has a steering wheel. It might be on a different side, but they all have steering wheels, and we can all drive that car when we get into it. So what do we want out of a network management system? We want that programmatic interface. We want to replace screen scraping. The screen scraping doesn't work. You spend a lot of time keeping up with vendor changes. The wild cowboy development engineer that changed a field to have a colon on it now. Well, you didn't anticipate that, and even if you are a regex god, it's not going to work. And you spend a bunch of time trying to fix that problem, and it was a complete waste. You could have done something else, played golf, whatever. But one thing to recognize, I think, on that is that the CLI has access to everything. It has more data than you can get from SNMP. There's no interest in replacing SNMP. It has value. We don't want to necessarily use XML or whatever that this programmatic interface might be to replace collecting statistics from interfaces. I think that would be a little bit more expensive than SNMP is at the moment. But we want to be able to access all this data. You want to be able to access the configuration, all the data that comes out of show interface, for example. And that is possible, I think, because all the data is already there. It's just a translation mechanism within the device. So Cisco gives you a show interface and it's in one format. Almost all, or perhaps all, that data is available on the Juniper, for example, and vice versa. It might be slightly different format, but if I can get it in some kind of a programmatic interface, then I don't have to screen scrape and I don't have to follow every single version of the operating system for that particular device. And I don't want vendors to choose my transport. I don't want to use SSL. I want to use SSH. I want to use Telnet. I want to be able to configure it over the TTY. I want my wire monkey to go down to the POP, push that box into the rack, connect his laptop to it, and run a script that configures it enough so that I can access it. I think the important thing there is that in the previous draft, I think it was Woody's draft, he says, well, I don't want to use FTP. I don't want that to be accessible. And I don't really want them to choose my transport. Let me make my choice for what fits my needs, right? If I have, sorry about that. If I want to use FTP and accept the consequences, then that's my prerogative. And I don't want the vendors to choose the language that I want to use, which is where ASCII or just text-based comes in very useful. I can manipulate it with whatever I want, awk, Perl, C, doesn't matter. It's up to me. This is just a way to format the data that you're going to put into it or take out of the device. And if at all possible, I want it to be human parsable. I want to be able to read it. It certainly makes debugging a lot easier when I can just read it directly rather than translating bits. And in some cases, one even wants to type it in manually. So things like XML that are purely text-based fit that requirement very nicely. It's very handy to be able to do that manually. And let's see, and one of the other things about SNMP, I forgot to mention, is that, like Randy suggested, it takes forever to get that MIB through the IETF and then implement it on devices. And I don't know, how long is it going to be before it breaks? Certain vendors seem to break that repeatedly. I can't live with that. If XML is, or this interface is just simply a translation, I'm hoping that that'll be more reliable in the long run. And the other thing I'd like to be able to do from an interface like this is I'd like to be able to connect to a device, I want it to tell me what kind of device it is, what version it's running, and or be able to query that. And I'd like to be able to decide how I'm going to translate the data that comes in or goes out to the device. So if I connect to a Juniper, I know it's a Juniper and I know I have to use a certain translation. It tells me, but the mechanism that I get that information to make my decision is all generic. I can connect to any device and it's going to tell me that. So does XML provide that to us? Certainly seems to. It has the capability to give us all of this data, and it gives it to us in a format that we can parse. And Juniper's made a considerable effort at implementing this, and they've done quite a good job. Is it necessarily the best way to do it? I couldn't say. Others have suggested SOAP, and I can't say if that's a better mechanism. Having looked at it only briefly, the libraries that I had seen available for SOAP weren't that impressive. So while XML has a plethora of libraries, and they're for all different languages, there's C, there's Perl, there's Python, so on, there's a certain momentum here. We have a lot of this stuff already done, and one vendor's already implemented it. And with momentum, there's perhaps some acceptance. So I hope that other vendors will embrace that. And how to express this? We'll see a lot more tools that are going to arise that already have this support, and maybe not every ISP, every user will have to invest the time into developing their own. But with the momentum, I think that'll take off. Let me see. There was some other notes that I had here. Oh yes. The one thing I think we need to see about XML is how these other vendors will accept, number one, what has already been done, and probably number two, how they will, if and how they will accept generic interfaces in this translation mechanism. I think I'll leave it at that.
Hi, my name is Phil Schaefer. I'm with Juniper Networks. I'm the software developer who works on the XML API for our boxes, and I'm going to talk about the draft for the netcomps protocol. There's a design team that worked on this. It's folks from Juniper, folks from Cisco, folks from Wind River, and some others. What we see as the key part of the strategy is to leverage what folks have, what vendors have in the CLI, to expose that those capabilities and the as easily as possible, and to bind the API to the CLI as tightly as possible, so that when a feature is available in the CLI, it's available in the API. We use XML for this because it's a great way to carry data. It's not only useful in our problem domain, but it's used in all sorts of applications for interchange between databases and applications. There's powerful technologies for doing data transformations on XML. XML is text. It's easily parsable. If there's bits you don't care about, you can ignore them without having to update your parser for every release of the vendor software. You may not understand the bits that you're parsing, but you can at least parse them and either discard them or retain them. This is my version of Randy's slide, sort of, where you have software that's maintaining databases of your basically your network definition. You can pull that data out into vendor neutral configuration. You can run it through transformations that may be vendor or product or release specific to generate configuration that you then hand to the box. So NetConf is really concentrated on getting configuration onto the box in a simple programmable manner. The protocol, 4 basic areas of features. The protocol has multiple channels. There's a management channel for controlling operations. There's an operation channel that carries the actual content as RPCs. And there's a notification channel for carrying asynchronous messages from the device back to the management application. The management channel can kill a session or abort a current an RPC that's in progress. The RPC mechanism is fairly trivial. You send an RPC XML element, you get back an RPC reply. On the management channel, you can receive progress indications, and you can send abort and receive in response an abort reply. The protocol is designed to be able to transport over to be carried over any transport, including SSH, SSL, beep, SOAP. Doesn't matter, or raw terminal device, console TTY. It shouldn't matter what's under it, as long as it meets a base set of requirements, which are spelled out in the draft. The protocol has a capability exchange where, at the start of the connection, each party gives a list of capabilities that the capabilities that it understands. The overlap of those two capabilities are considered to be what can be used for during that conversation. So if the client understands locking and the server understands locking, then any of the locking RPCs can be requested, and any of the responses can and the appropriate response is expected. The capabilities can be versioned. They can be standard, proprietary. The base capabilities are concentrated on configuration, get, set, copy configuration. There is a mechanism for getting state information just because it's convenient. When you're configuring interfaces, it's convenient to be able to get a list of interfaces. The draft defines a number of capabilities. The notification is a capability. So both sides have to express their ability to manage the notification channel before the channel can be opened. And there are a number of capabilities that we feel better express how devices in use in the network operate, like candidate configuration, separate startup configuration, the majority of boxes in your network have a model where they have they may have a candidate configuration, they definitely have a running configuration, and they may have a separate startup. The ability to access these is determined by capabilities, so you can generically say, you can generically determine whether your box has a candidate configuration, in which case changes made to the candidate configuration have to be committed before they affect the operation of the box. And there's a capability for startup configuration, so that you'll know that if you're making a change to the running configuration, it has to be saved to the startup configuration. And that's all I got. Not these slides. Not these slides.
Let's see. I think I can dig Andy out. I asked Phil if he can dig up some examples while Andy's singing his song. Let's see. Then there's somewhere here. There's full. Oh, this slideshow. Yeah. Andy, you're on. Oh, you got slides.
Yeah.
Well, do this. Then let's go to some hardcore examples, and then hopefully people out there, the coffee will have settled in, and somebody out there will wake up. First people I've heard.
Hi, my name is Andy Bierman, and I'm the co-chair for the NetConf working group. That's the effort that started up in the IETF for this. So the goal of the working group is to create a standard for programmatic configuration, and we really want to make sure that it's something operators want to use and vendors are going to implement. I've been doing SNMP for a lot of years, and so I'm very aware of what can go wrong and the divergence of what operators want and what vendors were working on and the IETF was working on. So we're kind of starting fresh here and hoping that we can get operators really involved in the process, so that we'll end up with something that they'll want to use. And I don't know how many of you here are involved in IETF working groups. I know it's no picnic. It's a lot of times it's contentious. It's a lot of effort. Things take way too long to get done. All those reasons why it's easier to just work on your network and forget about it. But I really hope that we can get some people here to participate in the mailing list and even attend meetings. So here's the working group details. If I think my slides will be online later if you want to get them from there. Or there's already a mailing list and an archive, and and one more plea to get involved, read drafts, even participate in email. You can even send an email to the chairs and say, hey, your group is getting off track. Well, I don't know why they're talking about WSDL on and on. We don't care about that. So we want to hear those kind of comments. Even if you don't want to send them to the group, you can send them to the chairs. So this slide kind of is taken right from the charter about some of the things that the protocol is supposed to be able to do. It's supposed to be able to retrieve configurations, be able to keep configuration data and state data separate from each other. That seems to be important. A lot of times diff tools show false positives because state data is included in the configuration. We want to avoid that. It needs to be extensible enough so that vendors can provide their own additional configuration knobs, and we can build on standard configuration. It needs to be a programmatic interface to get away from screen scraping. Everyone agrees on that. Use textual data. That seems to be a really strong requirement that keeps coming back to us. Supporting existing authentication mechanisms. This is still it's not clear how we're going to exactly do this to support the same sort of authentication that that's used for CLI, but we need to do that somehow. That's one of the goals of the working group. Also, to integrate with database tools. I think there's a lot of XML tools that let you do this. I don't know if we need any special support in the protocol, or if just, you know, that will fall out for free, but hopefully that's a goal as well. We want to be able to support network-wide transactions. First, we need to figure out exactly what this means. If it means just configuration and locking and rollback, or if it needs to be something more than that. You know, that's an explicit goal, to be able to make it easy to configure something across multiple boxes and have it all take at once or all back out at once. And also, we want to provide for notifications somehow. This came out as a requirement during the BOF, that people don't want to use a separate mechanism to receive like SNMP traps and then do their config through this. They want one protocol to be able to send notifications as well. So now I go into some of the issues that are kind of already decided in the charter, see what you guys think of them, if we've made any mistakes here. First of all, it's a peer-to-peer protocol. You know, we're sending unicast messages, probably over TCP, definitely connection-oriented, and the transactions are synchronous, although you have this ability to get progress reports that Phil was talking about. And either end can initiate the connection, so a device can connect to a manager. It helps get around firewall problems and that sort of thing. It's definitely session-based, so we want to be able to set up configuration or per session configuration parameters, security in use, the capabilities exchange, these sort of things get done once at the beginning of the session instead of on every transaction. And also the operational model is fairly important, that we be able to define features that can be extended in the standards group over time, and also vendors can add their own extensions. And you can identify these extensions by capabilities exchange. So you don't have to have a big offline database that says, for this particular version of that particular box, I can do this to it. We want to be able to get those capabilities in line in the protocol, and instead of maintain a data store of all that. So, some more issues already decided, not set in stone, but the working assumption is that they're decided, is that we want to be transport independent as possible, but we're assuming certain things about the transport, like it's connection oriented, and we want to be able to take advantage of security features in the transport layer and not reinvent all the security mechanisms at the application layer like SNMP did. There's going to be, I guess, some issue here of whether or not we're going to standardize any transports that aren't secure, like Telnet. I don't think we're going to do that, but that's certainly something that can be added on if someone really wanted to do that. We've already decided to use XML for the data encoding because it's a good balance between machine and human readable, and also, but it's not. We don't want to exclude the possibility that router or CLI chunks can be moved around with this protocol. So there's a notion that we should be able to use XML wrapper to send CLI text. It's not likely that vendors are going to just cut over to a purely XML driven configuration for all features. That's not realistic. So we have to be able to phase in the XML versions of the config. So a way to do that is to be able to move CLI around in the protocol as well as XML versions of the config. Probably the most important design decision that we made is to not work on the data model right away. So we will identify data model issues that affect the protocol, things like namespace management and other things like if there are naming guidelines or XML usage guidelines that we want to put in place. But the working group is not going to define standard data models for like BGP and things right off the bat. Hopefully, this will happen in the IETF. It'll happen in various vendors doing their own XML. I understand. So the big red flag here is that this protocol is not going to do everything from day one, from version 1.0. So there'll still be proprietary content around for a while. Hopefully we can work out the protocol issues, how to manipulate configs in a standard way, and then it'll be easier to figure out, start standardizing the data model. One of the reasons for keeping it separate is it takes forever to get stuff standardized in the IETF. And don't think for a minute that just because we move to XML instead of SNMP that it's going to go a lot faster to get all the vendors in the room to agree on what the knobs for a certain feature are. That seems to take a long time. Hopefully we can figure out how to speed that up, but so there's always going to be a lag between standards-based management and proprietary configuration. I don't see that going away. We can try to reduce the latency, but it seems to take a while to get the standards out. And we also decided that we're probably going to use XML schema to define things like the initial data types and the initial data modeling language. But again, the actual contents of the data models is still TBD. And if you think we should start working on that right away, then you should tell Randy to start working on that, get a working group going. Some of the stuff that's still completely up in the air and needs to be resolved is, by the working group. And by the way, the working group hasn't actually started yet. This next meeting will be the first meeting, the one in Vienna. Although there's been a fair amount of mailing list activity, it hasn't officially started yet. So some of the ideas for transport mapping is to use beep, to use SSL, to use SSH. These seem to be the three leading candidates. Well, we want to make the protocol as transport independent as possible so that it can be mapped over different transports as needed. Initially, the XML comp draft said we'd use beep, and we backed off of that when the worker group was formed and said we'll still need to decide that. The RPC layer seems to also be controversial. Some people want to use SOAP. Some people want to use the RPC that's in the XML conf draft. Some people just want to avoid the terminology RPC and call it a simple request response. We don't know what we're going to do there yet. Another big issue, and I think this is one of the biggest ones, is the advanced XML features, because this really depends on the tool sets, the kind of starting point for the operators of what kind of tools they're going to use to manipulate this stuff. I agree that it should be as tool neutral as possible. You should be able to use any language, and that's why I favor using plain XML as plain as possible, and not relying on WSDL templates and fancy features like XPath filtering within the protocol. But we'll need to decide that. The protocol operations has been a subject of discussion and haven't really resolved what we're going to do there. The way to do add, modify, and delete, I won't go into the details, but there's various ways to place that into the XML and what ramification it has on the granularity of operations and such. So that needs to be resolved. Certain things that are advanced features that we currently have as optional, some people think should be mandatory. Things like the ability to do checkpoint and rollback, the ability to do locking, and what kind of locking. Some people are saying we should do granular locking, so you can like lock just the BGP config or lock just interface Ethernet 0, something like that. Currently, the thinking is that we'll just have a monolithic lock, and a lot of people either like that or don't. So that seems to be fairly controversial. Multi-device operation support. We think this is just checkpoint and rollback and locking, but we need to look into this further, see what, if there's anything else we need to do to support the ability to push changes out on multiple routers and have them all take or all back out kind of reasonably at the same time. The error handling, I guess the format of error messages, how detailed they need to be, any things, special features like rollback on error, so you automatically leave the router in the state that it was in when you started working on the config if some part of it doesn't work. That needs to be worked out. And also the notifications, or we're going to use something like the secure syslog in RFC 3195, which runs over beep, or we're going to use something else. So some people want to use defined notifications that are in this protocol explicitly. So that's pretty much all I have. I was hoping there'd be some feedback from the group on which way we should go on these issues. So if anyone has any comments, let me know.
Questions and everything are welcome at any time. We're going to try and find a microphone.
It's kind of, informal participation, so no one's formally signed up to do anything. There are large service providers. SBC is very active in this, and some others as well who are interested in seeing this happen.
So in lack of questions, I'll give you some of my poison of answers. What we're trying to do in this effort is a serious step without going beyond what we know as engineers how to do. So it's stuff that's near to what's already being done. There are efforts underway in Juniper, Cisco, Procket, et cetera, in this area. As operators, I'm interested in that I can have my same back-end tool set, as Heasley says well, and generate a canonic configuration and then target the various vendors' variations of how they describe BGP. Do not get fooled by XML. It's just a wrapping language. It's just a way to tag data and marshal it. It doesn't have any magic about any of this. So it's a combination of XML, transports, and then the model you put over it. How many people here work in an environment where some significant aspect of their router configurations are generated automatically today? That should scare the hell out of you. I mean, all the other people here are your peers, and they're generating routes coming towards you God knows how. The problem is it's not easy to do today. When I left Vario, where I worked with these, and Andrew's around here somewhere where these Vario system came from, I expected to find the Vario was kind of in the middle of the pack. One other place I visited, a very large telco, where maybe 20% at most of their configuration is generated automatically. The rest is manual. And they had some of the top routing researchers of the world, scraping router configurations from the network and writing programs to check them for consistent routing policy. I said to the head of networking, this is like doing brain surgery with a proctoscope. You've got the wrong end of the animal. Generate consistent routing configurations. And as you try to scale, and as we try to scale our mutual network that we all run, this is where incidents like the 7007 disaster, et cetera, came from. So Andy, what are you doing? You darn near got it. Well, bring your laptop over here.
Andy, you mentioned something about, I'm not sure I caught the entire comment, about not doing Telnet. Can you explain that further? Because it's simple, it's always there. It's kind of like TFTP, right? You don't want to use it, but sometimes it just works so well. Right, and some places I can't.
The reason we would not standardize Telnet as a transport is because we wouldn't get it past the security ADs and IESG. That would be the first reason.
But it's already a standard.
What?
All you're doing is standardizing a data stream, right?
I'll tell you what the fantasy is. The fantasy is that if he says he's using, that this protocol must be used over an encrypted transport, that this will get past the security people. Of course, this tool set over which this is being transported, has, in the IETF protocols, no way of saying down a layer, by the way, are you secure? It's not there. Dr. Bellevin.
Speaking as one of the security ADs who won't bless Telnet for transporting something, I can't correct the sins of the past. I can sure stop new ones from being committed in that. I can't stop somebody from doing something stupid. I can say, if you're going to provide a facility, at least make it possible for people to do things the right way. If you want to transport this over Telnet, I can't stop you. If you want to go turn off the security, use null cipher with SSH, I'm not going to stop you. Publish your private key, but I want to make it possible for people who want to do it right to do it right.
Agreed. The Telnet thing is just a quaint little thing. Is when we first get these strange routers and things, the only transport they tend to have turned on is Telnet. So when I want to shove the initial configuration down it, and of course, then there's the friends in Washington, D.C. who won't let mean, nasty other countries get any encryption. Mike, just keep going. They're figuring it out.
Okay, I'll just speak loudly. There we go. As in the security AD for HP, David Rioch, I can't agree with you more. We're not going to allow Telnet, that's for sure. It doesn't matter. It's not a good argument that that's the way everybody does it, because we can't make our security rules based on the way everybody does it, because that's not necessarily the right way. So we're not going to allow that stuff to transmit across the network in the clear, the configs, let alone the passwords, etc. We're dependent on the devices as well to get the right kinds of communications that will support it. Right now we don't have a good SSH implementation on our boundary devices and things like that. So we've got it. This is a discussion that is part of the IETF working group that we're having here, but we do need to move away from the mentality of that's the way we do it, that's how everybody does it, is a Telnet, with all due respect. So.
I didn't say that. I said when I get that router, that's all that it has on it, and I've got to shove an initial configuration up it.
In this particular case, all you're giving me is data. Don't make the choices for me. I'll make my own choice. Make me aware of what's available. That sounds like drug policy in this country. right? Stop making choices for me. Give me the information I need to make my own choices, and from there, that's how you educate the people, and then they can make their own choice. Whatever works best for them at that particular point, right?
Well, there's a trade-off between flexibility and interoperability. As a vendor, we can't put, 7 different transports, for this protocol on the box. We'll be much more inclined to get, multi-vendor interoperability if we standardize a select few. And if people want to deploy, this protocol over Telnet, then I'm sure they will. If they want to deploy it over HTTP without SSL, I'm sure they will. But there's a difference between vendors providing this and the IETF sanctioning it as a standard. It may be a subtle difference, but it's a fairly important one.
Okay, I view it as all right, so now I log in and I have /bin/CLI, right? That's my shell, as it were. Now I log in and I have bin/XML, and that's my shell. However I log in, that's my decision. Does that make sense? Right?
Well, if you're using a tool to get into the box using this protocol, the vendor has to implement it. So if there's no agreement on what to implement there, then you have to, this is all ad hoc. There's really no standardization involved. I think the market will dictate if there needs to be a lot more transports or not. I fully expect people to do this over HTTP without SSL because they're already doing that. But it's not the same to say that the IETF standard way to do this is to just do whatever security you want. We don't care, because the security agencies care, and they have veto power over the document. Did you want to go to this the examples I got at it? I don't know if they're even up to date.
Just one more comment, please. I may be speaking from a narrow perspective and that of the enterprise, but from the perspective of the enterprise, for my enterprise's liability perspective, it behooves me to not allow that type of transport across my network, because it increases our risk of liability if that information is exposed to the public in any way, whether it typically would be from an internal capture of the data being put out on a news board or anything else. So my perspective may be narrow, but that's what the enterprise has to deal with, is we have to limit our liability.
That's valid. Absolutely.
Yeah, I think the IETF position is usually in this area to be to force vendors to supply a secure path, but they don't force operators to use it. It wouldn't be impossible to do, and wouldn't make sense. Phil, did you want to go over these examples, or?
So here's some examples of the protocol. This one is a get configuration from the running configuration. You're getting a bad echo. You're getting a subset of the configuration given by identified by a hierarchy of configuration. In this example, the users tag says get me the user's subtree of configuration. You can put an arbitrary hierarchical path of configuration in that configuration tag. The format can be either XML or text. Text will give you whatever the native format of the box is. XML will give you the configuration expressed in hierarchy of tags. So the reply for that from that RPC would be something like this, where you have the reply configuration tag containing the requested subset of the configuration, the subtree. In this case, it contains 2 users, one named root, one named Fred. To change the configuration, you do an edit configuration RPC, targeting the running configuration, some of the options you can provide, the format that you're providing the configuration in, and then under the config tag is the subset that in this case you're replacing. So you're replacing an Ethernet interface with this specific data. There's also a copy config RPC that copies from a source to a target. You have to identify the format of the configuration. The source and target can be URLs or the running or candidate or startup configuration or a local configuration, a named configuration database. There's also state operations. In this case, you do a get state. You identify in the state element what piece of what piece of state information you're after. In this case, the interface, the statistics for interface Ethernet 01 in XML. And here's the results of that RPC. The results of an RPC or an RPC reply with a matching ID attribute. And the hierarchy mirrors the hierarchy in the request. Doesn't seem to be. There's a delay.
I'll just talk loud, that's okay. Oh, good. So Phil, back a couple slides, since Randy said questions were okay anytime.
Anytime.
I've been meaning to ask you this several times. So when we put ours together, as you know, we had just not edit, we had replace as well as edit, and I just wondered why that didn't occur to you guys. Because you said, perhaps you just want to replace a section instead of edit it.
Right. It comes as the replace write option under an edit configuration.
Right. Okay. So you put it. Some of this is
as an option in the edit.
Is a option in the edit instead of the other way around. I just wondered why you did it that way instead of the opposite. Nothing other than we just took two different ways to get to the same path. Okay.
So from this example, one of the things I wanted to point out is that's completely an open issue. Is see that interface name equals Ethernet 0/1? That's just the author's choice who did the slide. I think it was me. But there's a lot of different ways that you can do naming inside the XML, and I think part of the standard has to be, what are we going to do for standard data models for how to do that kind of naming, because it impacts the authorization model for the security, and so it's kind of relevant to this protocol.
More questions? Well, let's break 20 minutes early. Whoops.